Welcome to Tomorrow's Tech, Unlocking the Future Today. Join us as we explore the next frontiers of technology and innovation. Subscribe and hit the bell to stay updated with all our latest content. Imagine a computer so powerful it could solve problems our current computers can't even begin to unravel. Sounds like science fiction, right? But what if it isn't? Today we're standing at the precipice of a new era in computing, one that's set to redefine the boundaries of what's possible. We've come a long way since the invention of the first electronic computers in the mid-20th century. These machines, which operate using classical computing principles, have revolutionized every facet of our lives. From automating complex calculations to powering the digital world we live in today, classical computers have been the driving force behind countless technological advances. Yet, they're not without their limitations. Classical computers process information in binary form as bits that exist in one of two states, 0 or 1. This binary system, while effective for many tasks, becomes increasingly inefficient as the complexity of the problem grows. Some problems are so complex that even the most powerful classical computers can't solve them within a reasonable time frame, if at all. Enter quantum computing, an emerging field that promises to overcome these limitations. Quantum computers operate on a different principle altogether. They use quantum bits, or qubits, which, thanks to the peculiarities of quantum mechanics, can exist in multiple states at once. This means they can process a vast amount of information simultaneously, potentially solving complex problems far more efficiently than classical computers. And it doesn't stop there. Quantum computers can also perform a process called entanglement, where the state of one qubit instantly influences the state of another, regardless of the distance between them. This could revolutionize fields like cryptography and secure communication, but before we get too carried away, it's important to remember that quantum computing is still in its infancy. There are many technical challenges to overcome, and it may be several years before we see fully operational quantum computers. So what exactly is quantum computing, and how does it promise to revolutionize our world? Stick around as we delve deeper into this fascinating field and explore the future of computing. Quantum computing, in its simplest terms, leverages the principles of quantum physics to process information. To grasp this, we first need to understand the fundamental unit of quantum information, the qubit. Unlike a classical bit that can be either a 0 or a 1, a qubit can be both 0 and 1 at the same time. This is due to a quantum phenomenon known as superposition. To visualize superposition, imagine you're spinning a coin. While it's in the air, it's neither heads nor tails, but a blur of both. Qubits in a state of superposition are akin to that spinning coin, embodying a blend of both 0 and 1. But that's just the tip of the quantum iceberg. Quantum computing also employs another quantum principle called entanglement. When two qubits become entangled, the state of one qubit gets instantly connected to the state of the other, regardless of the distance between them. Think of it like this. Imagine you have a pair of dice. You roll them, and no matter what, they always land on the same number. It's as if the dice are talking to each other, communicating their state instantaneously. That's entanglement in a nutshell. These characteristics of qubit superposition and entanglement enable quantum computers to process vast amounts of data and solve complex problems at a speed that classical computers can only dream of. But it's not just about speed. Quantum computing also opens up possibilities for new types of computations that aren't feasible with classical computers. It's like moving from black and white television to color. Suddenly a whole new world opens up. So, imagine a computer that can be in multiple states simultaneously, that can process a multitude of calculations at once, and that can solve problems that today seem insurmountable. That's the promise of quantum computing. This is the essence of quantum computing. The ability to be in multiple states at once and the power of entanglement. How does quantum computing compare to classical computing? Well, let's dive right into it. Classical computers, like the one you might be using right now, process information in binary form, ones and zeros, known as bits. Bits are like little on-off switches that, when arranged in complex patterns, can perform calculations, store information, and more. Now, quantum computers, on the other hand, operate on a whole new level. Instead of bits, they use quantum bits or qubits. Qubits can be both a 1 and a 0 at the same time, thanks to a quantum quirk called superposition. This means they can process a vast amount of information simultaneously, potentially solving complex problems at speeds that make classical computers look like they're stuck in the slow lane. But that's not all. Quantum computers also utilize a phenomenon known as entanglement. When qubits become entangled, the state of one qubit can instantly affect the state of another, no matter the distance between them. This introduces another layer of speed and complexity that classical computing just can't match. Now, imagine trying to solve a complex molecular structure or cracking a cryptographic code. A classical computer would have to go through every possible solution one by one, which could take an incredible amount of time. But a quantum computer, with its superposition and entanglement capabilities, could theoretically process all possible solutions at once, making it exponentially faster. But don't go tossing your laptop out just yet. Quantum computing is still in its infancy, and there are many challenges to overcome before it's ready for prime time. However, the potential is undeniable. Tech giants like Google and IBM are already in a race to achieve what's known as quantum supremacy, the point where a quantum computer can outperform a classical computer. The race is on to see who can harness this power first and usher in the era of quantum supremacy. Like all revolutionary technology, quantum computing faces its fair share of hurdles. Quantum computing, in its essence, is a complex dance, a balancing act of maintaining quantum coherence, error correction, and cooling requirements. These challenges are as intricate and interconnected as the quantum world itself. So, let's dive in. First up is maintaining quantum coherence. Quantum coherence refers to the delicate state in which qubits exist in a superposition of both 0 and 1. Maintaining this state is a Herculean task. It's like trying to balance a spinning top on the edge of a knife. The slightest disturbance, whether it's a cosmic ray, a stray electromagnetic field, or even a temperature fluctuation, can knock the qubits out of coherence, causing the quantum system to lose its information. This phenomenon is known as decoherence, and it's one of the biggest challenges in quantum computing. Next is error correction. In classical computers, error correction is a walk in the park. But in quantum computing, it's an entirely different ballgame. Due to the probabilistic nature of qubits, errors in quantum computations are not only possible, they're expected. And fixing these errors without disturbing the quantum state, that's like trying to fix a car engine while it's still running. The third challenge is cooling. Quantum computers are not your average laptops that you can run at room temperature. These machines need to be cooled down to near absolute zero, colder than outer space, to function properly. This is necessary to reduce the chances of thermal energy disrupting the quantum state. The cooling systems required are complex, expensive, and consume a lot of energy. Despite these challenges, tech giants like Google and IBM are investing heavily in this new frontier. They are pushing the limits of what's possible in an attempt to usher in a new era of computing. Quantum computing is not just a dream, it's a reality that's being built, one qubit at a time. It's a testament to human ingenuity and our relentless pursuit of knowledge. The road to quantum supremacy is long, winding, and full of obstacles. But then again, every revolution has its challenges, and as they say, the harder the struggle, the more glorious the triumph. Despite these challenges, tech giants like Google and IBM are investing heavily in this new frontier. With all its potential, what does the future hold for quantum computing? This is a question on the minds of many as we delve deeper into the realm of quantum computing. The potential applications of this technology are vast, reaching into various fields. In the world of cryptography, quantum computers could provide unprecedented levels of security. By taking advantage of quantum mechanics, we could create cryptographic systems that are virtually unbreakable, ensuring that sensitive information stays secure in the digital age. The field of medicine is another area where quantum computing could make a significant impact. Imagine being able to model complex molecular structures, leading to the development of new drugs and therapies. With the computational power of quantum computers, this could become a reality, potentially revolutionizing the healthcare industry. In finance, quantum computing can offer faster and more accurate predictions and analyses. This could lead to more efficient markets and better investment strategies, providing a significant boost to the global economy. The future of quantum computing is not just speculation. We've already seen tech giants like Google making strides in this field. In fact, Google has claimed to have achieved quantum supremacy, a term used to describe a quantum computer's ability to perform a calculation that a classical computer could not complete in a reasonable amount of time. This is a significant milestone in the journey towards fully functional quantum computing. However, it's not just about what quantum computing can do, but what it represents. It's a shift, a leap into a new era of computing. It's about redefining the boundaries of what's possible, challenging our understanding of the world, and pushing the limits of human innovation. As we stand on the brink of a quantum revolution, it's clear that the future of computing is anything but ordinary. We're stepping into a world where the rules of classical computing no longer apply, where the impossible becomes possible, and where our understanding of reality is fundamentally challenged. This is the future of quantum computing, and it's a future that's closer than you might think. As we draw the curtain on this fascinating dive into the world of quantum computing, we want to emphasize how invaluable your interaction is to us. There are several ways you can show your support. Give us a thumbs up if you liked our video. Share and subscribe to our channel for more content like this. Your thoughts on quantum computing intrigue us. Are you thrilled or dubious about this quantum leap? Share your thoughts in the comments below. Make sure to turn on notifications to stay up to date. Thank you for your support, and we are eager to continue exploring tomorrow's tech together.